Hello, this video is on integrating with the technique called substitution, and these are the basics. First of all, what is du? All right, we have lots of ways to represent our derivative notation. So we use f prime of x, sometimes we use y prime, and sometimes we might use this. This is Leibniz notation. It's the derivative of the dependent variable y, the derivative of y with respect to x. And so we're going to use this method when we're using substitution. So in finding the antiderivatives with the substitution method, we're going to use du over dx. So what is du over dx? Well, I said du over dx, but it really is the derivative of u with respect to x. But you can treat that little bar there as division. So for example, if your function is a u equals 5x plus 10, then the derivative of the function u with respect to x would be 5, because the derivative of 5x is 5 and the derivative of 10 is 0. Okay, so now we're going to use a little algebra. So if we get that du over dx is equal to 5, we can actually treat that sign as division and multiply both sides by dx. So then you have du equals 5 dx. Du over dx, or the derivative of u with respect to x, is a ratio that we can manipulate. So we're going to multiply both sides by dx. All right, so let's practice this. You can pause it and try it yourself or just follow along with me. So if you have u equals 6x cubed minus 2x, then the derivative of u with respect to x is equal to 18x squared minus 2. Then we can multiply both sides by dx, and you get du equals parentheses 18x squared minus 2 dx. And again, if you have u equals x to the 1/4, then the derivative of u with respect to x is 1/4 x minus 4 over 4 would give you negative 3/4. And then if you multiply both sides by dx, you get du equals 1/4 x to the negative 3/4 dx. Okay, why do we need to know this? When we use the technique of substitution, we're going to be finding du and dx in order to find the antiderivative. And we're going to need to use some simple algebra techniques to change the form of simple equations. So you have to know when to use u sub. You don't use it all the time. You use it when you have a variable expression that's raised to a power. So if you have a binomial expression or a trinomial expression raised to a power, well, you can't distribute that exponent in. So that's a huge hint that you're going to need to use u substitution. If you have an e function and you have an e to the power of a variable expression up here, then you're going to use u substitution. If you have an ln with something in here, and if you have a variable expression that's in the denominator of a fraction, you're going to have to move that up, and so you're going to multiply, and it'll be that x. The expression will have an exponent that's negative right here. So you can think of u, letting u represent the big ticket item, so to speak. So let's look at our examples. All right, so first of all, you can't use the basic rules where you have some function added to another function, subtracted to another function, for example. You can take the derivative of f of x, the antiderivative of f of x, add it to the antiderivative of g of x, and then subtract the antiderivative of h of x. So you can split those derivatives, but in order to do that, you have to have addition and subtraction in between those different function expressions. So here you've got multiplication. So that's not good. You can't split that and take the antiderivative of that times the antiderivative of that. That's not going to work. But what you can do is use substitution. So the first thing you do is you want to look at this expression, this binomial that's being raised to the 5th power. So that is what we're going to let u equal. Okay, then step 2 is you're going to take the derivative of this. I know we're in the antiderivative section, but you have to take the derivative of this u function. So that would be du over dx. The derivative of u with respect to x is equal to, and that derivative is 6x squared. Then we're going to multiply dx to both sides. So after a while, I'm just going to skip right to this step, du equals 6x squared dx. Okay, now the next step is you're going to divide by 6x squared to get dx by itself. But here's the reason. You see this 3x squared here? Notice that this 6x squared, that they both have x squared. So that's really good news. Okay, so what we're going to do is we're going to divide both sides to get dx by itself. And so dx equals du over 6x squared. Okay, now I'm going to put a box around this because it's important for you to understand why we just did all of this. Our objective is to create an easy antiderivative that we can take. And what I mean is we're going to try to get an antiderivative that looks like this. So you remember this rule? If you have a constant times a variable to a power, then to take that antiderivative, I always say that the constant comes on down, and then you can take that x and add 1 and get n plus 1 over n plus 1. And that's the rule when n does not equal -1. So we'll deal with the other one when n does equal -1 in a second, but that's what we're trying to get to. Trying to get to that. Okay, so back to this. What we're going to do is we're going to substitute. That's why they call this u substitution. And there are 4 parts. There's the integral, and then there's this first term 3x squared, and then there's this middle term 10 plus 2x cubed to the 5th, and then there's this dx. Okay, see those 4 parts? So you're always going to rewrite the integral because we haven't taken the antiderivative yet. And you're going to rewrite the 3x squared. But then right here, remember we let this be u, so we're going to change that to u to the 5th. And then dx, remember how we solved for dx? That's du over 6x squared. Okay, now why did we do that? Well, we still aren't going to take the antiderivative yet. This is where the algebra comes in. What we can do, that's over 1. So we can cancel those, divide out those x squared, and you're left with 3 over 6. So I'll put that in the front as 1/2 u to the 5th du. So see what we got? That's our goal, is to get a nice power. So now we can take the antiderivative. So now we're going to take the antiderivative. So this signage is going to go away because I'm taking the antiderivative. So 1/2 comes down, and then we're going to add 1 to 5. That's 6, and then you're going to divide by 6, and this is an indefinite integral, so plus c. After you take the antiderivative, the very last step, you can multiply 1/2 times 1/6, is to put this u, which was 10 plus 2x cubed, back in to the 6 plus c, and you're done. Sometimes people put that u back in too early. Remember, the whole point was to take the antiderivative of an easy term, and then you put the u back in after you take the antiderivative. Okay, so I've written down the steps for you so you can write those down or just refer back to this video. But again, the first thing you're going to do is you're going to let u equal the big ticket item, the binomial that or trinomial or whatever that's being raised to a power. And you're going to take the derivative using Leibniz notation. Then you're going to multiply both sides by dx and solve for dx. Then you're going to substitute in for u and dx. And then you're going to rewrite and cancel the terms. And then you're going to rewrite this into an easy antiderivative. You're going to take that easy antiderivative, and then you can substitute back in for u, and you're done. Okay, let's try another one. So this time we've got a little more going on, so we have to do a little prep work. We want to get this written so that there's no division allowed with integration. So first of all, we're going to need to get the radical out of the way, and then second of all, we're going to need to get rid of the quotient by changing it to multiplication. So this is x plus 2 over x squared plus 4x raised to the 1/2 power, which would then be parentheses x plus 2 times x squared plus 4x to the negative 1/2 power. All right, now we're ready. So step 1, we're going to let u equal x squared plus 4x since it's being raised to a power. Then we're going to take the derivative of u with respect to x, which is 2x plus 4. Then I'm going to multiply both sides by dx, and this is the last time that I'll do that. I'll skip right to this step right here. du equals 2x plus 4 dx. Now I'm going to solve for dx. So I'm going to divide both sides by 2x plus 4. So dx equals du over 2x plus 4. I don't want to jump the gun here on you. I want you to notice this. See this first term, x plus 2? See this 2x plus 4? On first look, they don't look the same, but do you see how we could factor out a 2 from 2x plus 4 to make that 2 times x plus 2? Okay, so that's going to be very helpful. All right, now remember, last time the whole reason we did all of this work here is we're trying to create an easy integral. And there are 4 parts: the integral sign, the x plus 2, the big ticket item, and dx. Okay, so we're going to copy down the integral and copy down the x plus 2. Now we're going to substitute in for u. And then dx, we're going to substitute that. du over 2 parentheses x plus 2. Right, now the next step is to use our algebra. We can cancel out because that's over 1. That's in the numerator. That x plus 2 divides out with that x plus 2. All right, so now you're going to have a constant that you can pull out. There's an understood 1 here, and that 2 is in the denominator. So when I rewrite this, it's going to be 1/2 u to the negative 1/2 du. And so now I can take that easy antiderivative. So I'm going to bring the constant down. So that symbol goes away because I'm now taking the antiderivative. And I'm going to add 1. So I'm going to add 2 over 2. So that's u to the 1/2. And then dividing by 1/2 is the same as multiplying by the reciprocal. And then we have plus c. And we just took that easy antiderivative. So now I can simplify 1/2 times 2 is 1. And that u will replace with x squared plus 4x to the 1/2 plus c. And just real quick, I do want you to know that you can check your work. So if we take our answer here and we take the derivative of it using the chain rule, That's going to be 1/2. This, don't mess with the inside. So 1/2 this to the negative 1/2 times the derivative of the inside, which is 2x plus 4, which is 1/2 times the square root of x squared plus 4x, and then times 2 times x plus 2. If I factor that 2 out, those two cancel, and you can see we have what we started with. So you can check your work. All right, let's do example 3. So again, we're going to have to do some rewriting because there's no division when you're integrating. So we'll rewrite this as the antiderivative of 1 minus x squared times x cubed minus 3x. We'll use that -1 to bring that up. So now we're going to let u equal this big ticket item, because this one isn't raised to a power, but this one is. So u equals x cubed minus 3x. Now we're going to take the derivative, and I'm going to skip a step this time. So I'm going to say the derivative of u is equal to, or du is equal to 3x squared minus 3, and I'm going to go ahead and put the dx over there. Now I'm going to solve for dx, so that dx is equal to du over, now as soon as you notice this and this, they're not the same, right? So I'm going to go ahead and factor out a 3, because that's probably what you would do. All right. Now, still not the same. But you see, this 1 is positive, and this 1 down here is negative. This x squared is negative, and this x squared down here is positive. So an easy way to fix that is just to factor out a -1. So what that will become is this will become -3 times -x squared plus 1, which is -3 times 1 minus x squared. So whenever you have opposites, you're really not that far off. You just have to factor out a negative. Okay, so dx is equal to du divided by -3 times 1 minus x squared. So now it's time to rewrite. Remember, there are 4 pieces. The integral, this one you always copy over, this and this. So these last two you substitute. So the integral of 1 minus x squared times u to the -1 times du over -3, 1 minus x squared. All right, now the algebra, this 1 minus x squared will cancel with that 1 minus x squared. Remember, there's an understood 1 here. So when we rewrite it, we get 1 over -3 u to the -1 du. Okay, so now it's time for me to remind you about the other rule. So we want to try to get our integrals in this shape when n does not equal -1. But what if n does equal -1? Well, then we can use this rule. So the antiderivative of x to the -1, remember, is the constant just comes down ln of absolute value of x. So that's what we're going to use here. So now we're getting ready to take the antiderivative. So we're going to lose this, and the constant comes on down. And the antiderivative of u to the -1 is ln of absolute value of u plus c. So after you take the antiderivative, then the very last step, you'll substitute back in for u, and u was x cubed minus 3x plus c. All right, you might be ready to try one on your own, so you might want to pause the video and try it, and then come back and see if you got it right. All right, so we have to rewrite this. So this is 3 minus 8x. That already looks like it might need to be, might have to factor out a -1, times the square root of 8x squared minus 6x plus 5. And it's in the denominator, and it's under a square root. So when I rewrite it, it's going to be -1/2 dx. So I'm going to let u equal 8x squared minus 6x plus 5. The derivative of u, 16x minus 6 dx. solve for dx. Dx equals du over 16x minus 6. Now let's say you don't notice. You can also do it this way. You don't notice what's going on. So once you get u and dx, now you can substitute. So that would be the integral of 3 minus 8x times u to the negative 1/2 times du over, and now you want to start looking. So if you pull out a 2 from this, you get 8x minus 3, but those are opposite. So I'm going to pull out a negative 2, which is going to give me negative 8x plus 3, which is the same as that. So now the algebra, we're going to divide that out, and will be understood ones right there. So that's going to be negative 1/2 u to the negative 1/2 du. So we have our quote-unquote easy integral. So it's time to take the antiderivative. Constant comes down. Add 1. So 2 over 2 plus negative 1/2 is 1/2. Dividing by 1/2 is the same as multiplying by 2. All right, so now we can replace the u with 8x squared minus 6x plus 5, and I'll simplify that. That's negative 1. And it's 8x squared minus 6x plus 5 to the positive 1/2 plus c. Okay, pause the video and try this one. When you come back, I'll have the answer for you. All right, you should have gotten 1/12 times the natural log of absolute value of 1 plus 9 q to the 4th plus c. If you did not get that, just pause the video and look at my work and your work and see if you can find your error. Okay, now we have a new type, and these are e functions. So if you have a product, 3x cubed, times an e function to the 6x to the 4th, there is just a little tweak we need to make. What we're going to do is we're going to let u equal not the whole e function, but just the power. And you'll see why in just a second. So we're going to let u equal 6x to the 4th, and then the rest of it is the same. So the derivative of u would be 24x cubed dx. Solve for dx, and that would be du divided by 24x cubed. Take your information and take time to rewrite a new easy integral. So we're going to copy down the integral sign, the 3x cubed, and e to the u. And that's why this is going to work, because the antiderivative of e to the u is e to the u. So that's why we just let u be the power. All right, and then we have times du over 24x cubed. We're going to use some algebra. The x cubes divide out, and you get 3 over 24 e to the u du. Constant comes down. We'll reduce that. That's 1/8. The antiderivative of e to the u is e to the u. So you have that. So that's 1/8 e to the 6x to the 4th plus c. Let's do another one of those. So again, remember, if you have an e function that's being multiplied to something, you just want u to be the power of that e function. And we take the derivative, so that's 8x minus 3 dx. And then we solve for dx, so that's du over 8x minus 3. We have u and we have dx, and we're going to copy down the integral, copy down 56x minus 21, e to the u du over 8x minus 3. Okay, now again, this time there is nothing to pull out here, but there is something that we can factor out here to make these be the same. And so if you pull out a 7 times 8x cubed, 8x minus 3 gives you back that. So we factor out the 7. Got to do that little bit of algebra sometimes. And so now we can divide out the 8x minus 3, and we're left with 7e to the u du. All right, now that antiderivative is super easy. 7 comes down, the antiderivative e to the u is e to the u plus c. After you take the antiderivative, very last step, you can put that u back in, which was 4x squared minus 3x plus 5. Okay, so now you know how to use u substitution with e functions, but I do want to tell you that there is a shortcut, but you have to inspect it properly. So I will tell you the shortcut, and it is this. If you have an e function and the power here is a linear term, or degree 1 term, or the x is x to the 1. See that? 4x to the 1. So if you have that, we'll use u substitution on this first one, but you'll see the shortcut. So u substitution will work here, just like before. If we let u equal the power, 4x minus 3, then the derivative of u equals just the constant 4, and then dx. So if you solve for dx, that's going to be du over 4, which gets you the integral of 5 times e to the u times du over 4, which is 5 over 4 e to the u du. All right, and the antiderivative of 5 over 4 e to the u is constant 5 over 4 comes down, and the antiderivative of e to the u is e to the u, and that's the antiderivative of the easy integral, and so then you put u back, and you get e to the 4x minus 3. Okay, so look at the shortcut. If this is degree 1, then the derivative of 4x will be 4. And it's always going to end up being on the denominator. And so the shortcut is, if you have a linear power here, it's just going to be 5 over that leading coefficient, e to the 4x minus 3. And we like to use that shortcut a lot, so it's worth knowing. So here we have another linear power. So the derivative of 5x plus 8 is just going to be 5. So what you can do is just take that 2, divide by that 5, and e to the 5x plus 8. So it's a nice rule. It's a nice shortcut. Okay, so I just finished what you'll probably see, but occasionally you get these interesting ones where you might not realize what you have to do. So it usually involves these e functions. So first thing we want to do is rewrite this, because there's no division ever. So that's going to be rewritten as ex times 1 plus 2 e to the x to the negative 1. And so once you rewrite it, it might come clear. First of all, you see 2e to the x's. That's strange. But more importantly, you see how you have this binomial to a power. So you might say, do I let u be the power of the e, or do I let u be this? Well, you're going to let, even though there's e to the x in here, you're going to let u be this binomial because it's raised to a power. So once you figure that out, then everything's going to come out okay. So I'm going to let u equal 1 plus 2 e to the x. So the derivative would be, derivative of 1 is 0, and the derivative of 2e to the x is 2e to the x. So then if you solve for dx, you get du over 2e to the x. And then if you rewrite that, the integral of e to the x times u to the negative 1 times du over 2e to the x, you can see what's going to happen now, right? E to the x's divide out, so understood 1. So that's 1/2 u to the negative 1 du. And the antiderivative of that is 1/2 ln of absolute value of u plus c. And that's 1/2 ln of 1 plus 2e to the x plus c. All right, so example 11, let's try one more like that. I will pause the video. When you come back, you'll see the answer. So try this one on your own. All right, did you get that? All right, so did you know that you needed u to equal the inside this expression that's raised to 1/2? And then the derivative of 2 plus e to the x is e to the x. Then solving for dx, you get du over e to the x. So then you copy down the integral, the e to the x, change that to u to the 1/2, change that dx to du over e to the x, and these divide out. So then you get the integral of u to the 1/2 du. So to take this integral, remember you're adding 1, so 1/2 plus 2 over 2 is u to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3 plus c. And then after you take the antiderivative, you put u equals 2 plus e to the x back in for u, so that's 2/3, 2 plus e to the x to the 3/2 plus c. Okay, so that's u substitution. If you want to stick around, you can try these 4 and then come back and see if you got the answers right. Good luck. Okay, here are the answers. 1, -5/16 times parentheses 8 minus p squared to the 8th power plus c. Number 2, -10 over 9 times 10 minus x cubed to the 3/2 power plus c. Number 3, 1/2 e to the 6x minus 2 plus c. You could have used the shortcut there. Number 4, 7/15 times e to the 5x cubed minus 2 plus c. You could not use the shortcut there.